Hello and welcome to this video for Chemistry 20 in the gases unit. In this lesson, we are going to look at something called the law of combining volumes. Okay, there's a couple of different ways that this can be taught, but I introduce this as a stoichiometric calculation. So stoichiometric means you are trying to find the information of one substance in a chemical reaction relative to another substance. And specifically, it's volumes that we're going to be focusing on. So when I have a chemical reaction of gases, the relative volumes of everything in a reaction, they all are relative in very simple proportions. Okay? And so, for example, if I have the following reaction, the formation of ammonia, 1 mole of nitrogen reacts with 3 moles of hydrogen gas to produce 2 moles of ammonia. Now, if these were actual volumes, that would be the relative ratio of their volumes. So, for example, if I had 5 liters of nitrogen, hydrogen has a 3, whereas nitrogen has a 1. So hydrogen would be 3 times, or 15 liters. And then my ammonia has a 2, whereas the nitrogen had a 1, so it would be double the hydrogen. Okay? So the volume ratios are the same as the balancing coefficient ratios. And this is where we're going to apply, like I said, a stoichiometric calculation. Now, this is a formula you're going to see come up in every unit from now on in Chem 20. So it's good to wrap your head around. Now, not only applying it to volumes, but applying it to concentrations and moles. Okay? So what this formula stands for, the VW stands for the volume of the wanted substance in the question. You're going to be asked, what is the volume of one of the gases in the question? You are then going to be given the volume of one of the gases. And in order to find the volume of the wanted gas, you're going to take the volume of the gas that was given and multiply it by the balancing coefficients, wanted over given. So the wanted, again, is the gas you are wanting to find the volume of. The given is the gas you are given the volume of. You're going to use those balancing coefficients. And that right there is how we do stoichiometry. Okay? Wanted over given. Balancing coefficient ratios. So let's look at some examples. I have ammonia being formed in a composition reaction. So the question commonly, or the tough part, I guess, that students have within the gases unit is knowing when to use which formula. You'll see these questions are different than all the other questions we've done before, is because you are given the volume of one thing and you are asked for the volume of something else. Okay? And that's it. That's all you have. One volume, you're looking for another volume. But you also have a reaction. So that's what you need to start with, is a balanced chemical reaction. So if ammonia is being formed, ammonia is on the front of your periodic table, a common molecular compound, NH3 gas. The two elements that make up ammonia are nitrogen and hydrogen. We need to write their formulas, though, how those elements appear when they're by themselves in nature. Nitrogen is diatomic, so it's N2 and it's a gas. Hydrogen is also diatomic when it's by itself. Remember, the diatomic elements are Haber-Finkel. So hydrogen, oxygen, nitrogen, bromine, chlorine, iodine. Now I need to write balancing coefficients in front of these gases to balance this reaction. I have 2 nitrogens on my reactant side and only 1 in ammonia. So I'm going to multiply ammonia by 2 to get 2 nitrogens. But remember, that also now gives us 6 hydrogens on the product side. So 3 times 2 will give me 6 hydrogens to match on the reactant side. I can put a 1 in front of my gas that doesn't need any other balancing coefficients, and I now have my balanced reaction. Now, you're essentially treating the balanced reaction as like the header of a chart. I have 3 gases, nitrogen, hydrogen, and ammonia. Okay? I am looking for one of those gases, and I am given the volume of another one of those gases. So I have to start by writing that information down. It is asking me to find the volume of nitrogen. So nitrogen is the volume I want to find. I'm going to label that as my wanted substance. Okay, I'm going to put a W on top of it. That is my wanted gas. I am given 100 milliliters of ammonia. So my ammonia is the volume I'm given. And I can leave it in milliliters, whatever units I start with or what I'm going to end up with. Now my ammonia, I am labeling with a G to represent that my ammonia is my given. The hydrogen is nothing, right? I'm not looking for it, I'm not using it, it's irrelevant in this question. Now it makes part of the balanced equation, so you have to write it, but we're not using it or doing anything with the hydrogen at all, okay? So to find the volume of my wanted, my nitrogen, I take the volume of my given and multiply by the balancing coefficient, the 1 in front of the wanted, divided by the 2 in front of the given. Okay, so again, if I put my numbers in, my given volume was 100 milliliters. That was my given volume. And then I multiply by balancing coefficient, the number in front of the wanted, which is a 1, divided by the number in front of the given, which is a 2. So I'm multiplying by 1 over 2. So the volume of my wanted is 50 milliliters, but I need 3 sig digs, so it would be 50.0 milliliters. Okay? So again, always label your wanted and your given gases, because those are the balancing coefficients that you use here to find the relative amount of nitrogen compared to ammonia. And looking at the balancing coefficients, right, this should make sense. I have a 1 and a 2. So I should have half the amount of nitrogen as ammonia. Let's look at a couple of other examples. These are examples that I have for students in their workbook. So we have the following reaction, and I'm going to just write it down again because, like I said, I treat it like a chart, and those are the headers of my chart. I have 1 mole of xenon gas reacting with 2 moles of fluorine gas, and I am producing 1 mole of xenon tetrafluoride gas. Okay? So again, I have xenon, fluorine, and xenon tetrafluoride. I am being asked what volume of fluorine is required. So fluorine, I want to find the volume of my fluorine. We are told that it is consuming or using up or reacting with 85 milliliters of xenon gas. This is my xenon gas, and that given volume of it is 85 milliliters. Okay, so the xenon tetrafluoride we're not dealing with at all, it's just the fluorine and the xenon. So in order to find the volume of my wanted again, I take the volume of my given and multiply by the coefficient, the 1 in front of the wanted, divided by the 1 in front of the given. Okay, so my given volume was 85 milliliters. My coefficient in front of the wanted, my fluorine, is a 2. And the coefficient in front of my given, my xenon, is a 1. So I'm multiplying by 2 over 1, which gives me 170 milliliters. Now there's only 2 sig digs in the volume given, so I can only have 2 sig digs in my answer, which means I can only keep these digits. Right now, there's an invisible decimal in this number at the end of this number. If I'm cutting off the decimal, I have to put my answer into scientific notation, which means I'm moving the decimal to after the first digit. So I'm recording my answer as 1.7 as the 2 digits I'm allowed to keep, but then I need to say times 10 to however many places I move the decimal over. I moved it over 2 places to the left, so it's a positive 2 exponent. So 1.7 times 10 to the 2 milliliters. Now you could also take this and divide by 1,000 and convert it into liters. You would have 0.17 liters as 2 sig digs because leading zeros don't count. So you could record your answer either way. Okay, we have one more example and that'll be it for this lesson. For my students, this is question 4 in their workbook. We are taking propane, told what propane is, and burning it. Okay, so this is a hydrocarbon combustion reaction. There's a lesson video back in the Review of Science 10 unit that we did that reviews how to write a hydrocarbon combustion. So you can watch that video if you need more practice with it. But a hydrocarbon combustion means your hydrocarbon, in this case propane, is reacting with oxygen gas, which is diatomic, and the products of a hydrocarbon combustion are always CO2 gas and H2O gas. Both of them are gases. Okay? To balance this equation, I have 3 carbons, so I'm going to put a 3 in front of my carbon dioxide. I have 8 hydrogens on my reactant side and 2 on my product side, so 4 times 2 will give me 8. Now we add up the oxygens on the product side. There's 6 from my 3 carbon dioxides and 4 from my 4 waters. So that's 10. So 5 times 2 will give me 10, and then I can just leave a 1 in front of my other compounds that didn't need a coefficient. Okay, so if we break this up into the individual gases, I have 4 gases here. Now we are being told that we have 8 liters of propane, so that is my given volume, 8 liters of propane. I'm labeling propane as my G, my given. It's asking for the total volume of the gaseous products. So my product is carbon dioxide and water vapor. I want to find the volume of each of those gases. So to find the volume of my gases, again, we take the given volume, which is 8 liters, and multiply. I'm going to write the formula up here. Volume wanted equals volume given times wanted over given. Okay? In front of my wanted, which right now is the carbon dioxide, there is a 3 in front of it. And in front of my given, which is the propane, there is a 1 in front of it. So the volume of my carbon dioxide is 24.0 liters to proper sig digs. Now I also want to find the volume of my water vapor. So again, I'm using the same given volume, the propane, and I'm multiplying it by wanted. This time my wanted is water, so it has a 4 in front of it. My given is still the propane, and it had a 1 in front of it. So the volume of my water vapor is 32.0 liters. Now the question asks for the total volume of the products. So the total volume of my products, I'm going to add the 2 together, 24.0 liters plus 32.0 liters, and we get an answer of 56.0 liters. 3 sig digs in our answer. Okay? So that's kind of the toughest way that these questions can get, if it's asking for the total of the products. You find each and then add them together. And that is it for law of combining volumes. Thank you for watching this video.